Thanks for coming. Thanks for coming after lunch. It's okay if you fall asleep, I get it. This is deploying an observability stack in one line of code. I'm Anthony Nocentino. I'm a principal field solution architect at Pure Storage. I specialize in system architecture and performance. I like to design systems. I like to make things go fast, right? Cool. But that's not why you're here. Let's talk about what we're going to talk about today. We are going to deploy a monitoring platform, but I want to talk about why, right, and understanding what observability really is in a system, right? We'll get into all that. We'll talk about building meaningful dashboards and metrics, right? We want to tell a story because if I'm a very smart person, I want the things to be presented to me in the most simple way so I can make a decision about a potential anomaly in a system very quickly. We're going to talk about the architecture of a specific monitoring platform that we're using at Pure, which you can also use in your universe, and I'll talk about that in more detail. And the fact that I'm going to deploy this whole platform in Docker. And we're going to do lots of demos. The idea here is you can actually lift this code up and run it on another device and go in one line of code. And that's the idea is I've built, or I've taken advantage of some existing automations in various parts of the automation stack so you don't have to go and do things like connect to databases, connect or import dashboards, all that stuff's going to happen for you automatically, right? Cool. So the question really is why? Even before I came to Pure, I was an independent consultant for a very long time, and customers would call me and they would be like, hey, we're having performance issues. I'm like, do you have a monitoring system? And chances are most of them did not, right? And that became a challenge because then I had to go and find the performance issue in the platform after the fact, right? And so I see this time and time again because, you know, in small to mid-sized businesses, this is generally the case because they don't want to go and buy a monitoring system, right? Because they're generally pretty expensive. And if you do have a monitoring system, they're often point solutions, right? I have monitoring tools for VMware. I have stuff maybe for my physical hardware. I'm pulling metrics from the Azure portal, right? We're going into the Azure portal and visualizing them there. And that can be challenging too, because now I have data in different places that is controlled by that single team, most likely, right? But this is what's really happening in large-scale systems, in large-scale environments, is people realize they need visibility across those domains. Right? Nobody cares about the CPU utilization on an individual VMware host. They care when somebody clicks a button in your application, does that thing actually happen in a timely way for the user that clicked that button to get that thing, right? Especially if you sell stuff, this is critically important. And so you want to measure things in those terms. But in the end, when it comes down to it, a computer has 3 or 4 primary resources, CPU, disk, RAM, right? And networking. And so one of those things will likely be a bottleneck at some point in time, but you have to figure out why. Right, and that's really the story that you're trying to tell when you build a monitoring platform. Cool. The data indicates that there's no data. So we're going to talk about VMware specifically just as a use case. We're not going to dive too deep into its metrics, but if I have a virtual machine, right, it's going to sit on a physical server, right? Yeah. That might be connected to some storage network, right? Shared storage, and there's an interconnect there, and then eventually it's going to connect to a storage device, right? So let's talk about all the things that I have to monitor in this stack, okay? Oh yeah, and the fact that my data lives there, and that's the I/O path. And so being a storage company, we focus a lot down here, or I do at least, especially even as a DBA, because in the end, I have to read data from disk, get it into memory to get it to a user. So look at all the places I have to figure out where I have to monitor, right? That's a lot of places, okay? SQL Server's got DMVs, Windows has Performance Monitor, vSphere's got its own metrics, my networking team's going to have a metric, some things inside of the fiber channel network or Ethernet network or whatever that is. And then there might be vendor-specific tools here, right? And so I want to be able to paint a picture of, well, where potentially is the performance bottleneck in this stack, right? That's a lot of stuff. That's managed by a different team. That's probably managed by a different team. That's managed by a different team. That's probably managed by a different team. That's definitely managed by another team, right? So that's a lot of people that have to come into kind of like expose their systems for other people to monitor potentially, which means like you're like have to look behind the curtain and be like, oh, that's what's really going on there. I'll tell you a quick story. I worked as a consultant in a very, very, very large healthcare system, and when you walked into the emergency room and your doctor walked into the emergency room, opened up your chart. When they clicked to open up your chart, it took 38 seconds for your data to load. In an emergency room situation, does that sound like a good thing? And I clicked again, and I had to wait 38 more seconds. So the director that was in charge of that whole platform was like, listen, figure this out. And so I got a person from each one of these teams in the room, right? Everybody had their own metrics, except these folks, the networking team. And what wound up being an issue was the storage interconnect between the physical server and the tucking, because they thought they had 4 ports configured, but really only 1 port was active, so they were queuing all their I/O. And that manifested itself as a very critical application issue, right? And if we had metrics to help us find that, and I'll show you later, we're gonna talk about time correlating these things, that would have been very evident to see in a platform, right? The latency would have popped up here. We would have seen it. I'm gonna show you at the end a situation where there is that disconnect between 2 charts. So we can go find a little bit deeper. So what's observability? We always start here, performance, right? CPU, disk, RAM, network throughput, latency, IOPS, those kind of things. And availability is another element of performance. When you start building distributed systems or scale out platforms, there's an expectation that N number of devices are up supporting your workload. If there's an expectation of 100 web servers, 80 of them go down, what's gonna happen to the end users? Sadness, right? So availability is also a primary concern when you're building a platform. But as I indicated earlier, it really comes down to applying the metrics that we need to have a satisfactory experience for the consumers of a system, right? That's critically important to you and your business, or your company's business, or I guess if you own the business, but whatever. And it comes down to this fancy buzzword, full stack observability, right? That picture that we looked at a second ago, I want to be able to understand what's happening across that entire system, but more specifically the platform, right? It's understanding that there's a wider thing that supports the business that you're working with, not just the point solution of an individual system. And so that's where I started spending a lot of time working with our customers. And previously in my consulting business, and I'll zoom into this chart, don't focus, it's pretty small to look at from the audience, but this is what's called a Grafana dashboard, right? Grafana is an open source tool that allows you to visualize data, okay? And so these are different panels and charts that I've created that visualize certain metrics that are very important to a SQL Server DBA, right? And so what we're looking at here is I want to kind of tell the story very quickly and graphically of what's going on in this platform, right? So CPU being a very critical metric, I can see that right there. Something happened right at that point in time. Right. Anthony did something bad to the database intentionally, but that's what occurred. Yeah. And so we see CPU go up, and we see this thing called page life expectancy go down. These are things that mean something to a database professional, right? Page life expectancy is the amount of memory or amount of time a page is in memory before it gets evicted out because I had to read I/O off of disk, right? And the shorter that time that means I'm reading a lot of I/O off of disk, which is the next thing that we see. There's a thing called wait statistics inside a SQL Server that tell me a particular thing. Whenever SQL Server is waiting to do something, a counter increments. And in this case here, I have an SOS scheduler yield wait because SQL Server is a non-preemptive scheduling system, which will use up its quantum and then get switched off. So the SOS scheduler yield means I have lots of processes that are running for a long period of time and then getting switched off, right? Because it's a non-preemptive scheduler. Yeah. Kind of walking down that stack, now I can see that within an individual database, I'm having a ton of reads, right? And so I'm trying to tell the story to get me to understand like where things are going wrong. And not a lot of writes are going on. We also have the ability in a platform like this, and this is all stuff that I constructed in this specific dashboard, is to drill down to a particular instance. Because that's only one instance, and I have lots of instances being visualized on this chart. I think 5 SQL servers, right? So you can have a whole platform's worth of databases exposed to you in this way. And so let's drill down even further. So I want to know who is having a bad day. And so here we can see that this individual SQL server is now spiking at about 60% CPU, and we can correlate that here and see that our PLE went down pretty low. Okay. But these are just symptoms. They're not really telling me the story about what's going on inside the platform. And so as I go down even further, As a second ago, SOS scheduler yield means a specific thing to a database professional, domain context. That's really what we're trying to convey here. And that we're having a ton of reads into an individual database. So now I can very quickly get, as I scan down that page, go, oh, all right, there's an issue in this exact database causing something to occur, right? There you go. Quickly identify the database. And so in this case here, what I'm doing now is I'm extending beyond just SQL Server now. So this is the database read latency for individual database files inside of a SQL Server. But I'm also correlating that against metrics coming out of one of our devices, a flash array. This could be any device. And so at this point in time, I'm starting to figure out what's going on, because when I look at these two things, there's a disconnect in the values. So SQL Server is running about 3 or 4 milliseconds of I/O, and flash arrays are porting just over a millisecond of I/O. So there's something going on in this platform that's not, I actually left out intentionally, that there's some queuing happening in the hypervisor level inside of ESX. But the idea here is I can very quickly identify that issue by looking at this chart, right? There's a disconnect between these two things, and I know where else to go look. And I also know what's going on inside the database server. People are doing pretty bad things, or I was doing pretty bad things. And so the idea is being able to take metrics and time correlate them. I'm going to show you how to do this when we get into how I built this dashboard. Cool. Any questions or comments, team? We good? All right, cool. So when you're looking at a modern monitoring architecture of a platform like that, where I have many different things that I want to report on and time correlate, there's 4 different elements that we're going to kind of have to bring together. We've got to bring together the source systems, like the databases or the SQL servers, the flash arrays, or whatever I want to monitor. And then there's something to collect that data, right? That's a data collector. Then I got to take that data, stick it somewhere in a data store, because they need to be persistent, and then visualize that. And so there we see those platforms that I want to monitor. And in our world, one of our field solution architects in Italy wrote what's called an open metrics exporter. We're going to talk about what that is in more detail in a second. But what that does is that goes and reads from our APIs on our devices and extracts the performance data, puts it in a particular format, which is a standardized format that's defined by Prometheus, which we'll talk more about in a second. And then what it will do is stick that into a data store, right? Now, there's an open source project called Telegraph, and Telegraph implements different modules, and those modules are used to monitor things. SQL servers, VMware, Azure, all those different things. And so I didn't have to go build that. I just grabbed that off the shelf, I configured it, and now I have the ability to pull metrics in from SQL Server. And so these data collectors are pulling the metrics in from the various devices, and then Prometheus is a time series database, which means I can build correlations on time and tags, and we'll talk about how we do that in a second. And then honestly, this is absolutely the hardest part right here, is visualizing that data, right? Making meaningful charts. I banged my head into that Grafana thing for a long time earlier this year, getting those cool charts to come up. Because it was new to me, and I just had to figure out what was going on, right? Cool. So Telegraph, being a data collector, you can monitor all these different things. There's a link to its GitHub repository there as part of the Influx data project. And so you can get metrics from all these different things and build those correlations, but there's other different types of monitoring platforms to extract data. Right? Cool. So let's kind of zoom in on what we did inside of Pure, more specifically Eugenio Grosso, one of our FSAs in Italy. And so there's a design pattern from Prometheus. When I say design pattern, kind of in the programming sense, that tells you how to go and do this thing, right? Our devices expose performance metrics via the APIs, right? So we can ask for an object, and in that object will be the properties of that thing, and in that thing will be some performance metrics that can be emitted. And so the idea is you could do this on your own in your platforms if you have that same capability, right? The Open Metrics Exporter project also specifies what that metric output should look like. And so we're going to be reading from our devices via REST, put it in a particular format and structure, and then sticking that into Prometheus, right? And so the idea here is we're pulling metrics from that target system, the one we want to monitor, and then pulling that data across into Prometheus. And it's generally going to be via HTTP or HTTPS. But there's also another option, and I've done this before in other platforms like Datadog and New Relic and things like that in my consulting business, is when you actually instrument in your application code, right? This is like the holy grail of where you want to be, because now it's a push, and it's a lot more efficient than a pull from the platform that you want to monitor. So when an event occurs, we can emit that event into a target platform. Because if you think about this model here, when you're using an exporter, there's a thing pulling from many devices versus having many devices push into a data store. And one of those will potentially be more scalable than the other over time, right? When you start building big systems. And so that's what you have to consider. What's better, push or pull? But what's hard? Touching application code, right? And so it's going to be situationally specific. But if you're in this universe of building it on your own, you're generally going to be pulling. And we're going to revisit a really bad design decision that Anthony made in January when he's kicked this project off, and talk about why it was bad, and then what I'm going to do about it when we're done. And so this is a link to the project at Prometheus that defines that interface that you would implement inside of your own exporter if that's the way you want it to go. It's pretty elegant and simple. Our platform is built in Go. You basically connect to the array via REST. You do some magic with regards to some string manipulation, and then you stick it into Prometheus. So in that architectural diagram where I showed you kind of the 4 different things where we had the data sources, the data collectors, the data store, and the visualization, there's lots of components that have to be installed and configured and deployed, and you have to touch a lot of things. In fact, some of the folks, most of these projects, you can just download the binaries and install them via a package manager. But that's hard, right? And containers make those kind of things simpler. And all of these projects provide containers to implement the functionality that we've been talking about. Who's used Docker Compose? Awesome. Okay, this is going to be easy. What Docker Compose does, though, is it starts up containers. It can assert some configuration, right? So I can define what a system looks like. And that's what we're going to do, is we're going to take that graphic that I showed you a minute ago, and in Docker Compose, we're going to define what that system looks like, and also handle some of the networking shenanigans that we have to do with regards to how these systems all communicate with each other. And then we're going to take that and expose our Grafana to the public network, right, so people can consume it. And so you really wind up with this, kind of an orchestrated, defined solution in code, giving you the ability to run one line of code. But really, there's not one line of code, but there is one line of code. And you can run Docker Compose pretty much, or run the platform anywhere you have Docker. And then I get to use these really cool marketing icons, like this little whale thing right here. And so let's get into some things. So to do this, what do you really need? Docker or some other container runtime? And it can run anywhere. I do all the development of this on my laptop, but if I'm doing this for real, I'm not doing it on my laptop. I'm going to do it on real Linux running regular old Docker, right? Because I want to add some persistency to the platform, specifically around databases or around the data in Prometheus. And also, the idea is I want my monitoring system on all the time, not when I close my laptop, right? Cool. For this specific system, we'll need a SQL Server to monitor. And we're going to talk about time correlation in our platforms. And that first example of time correlation that I showed you was a SQL Server metric and a flash array metric, right? So I needed a way to say, this SQL Server lives on that volume, right? And you're going to have to do this, you have to solve this problem across any platform that you build. If you're going to connect time correlated metrics, because you have to add that context to the thing that you're consuming, right? And so inside of our platform, the only way I was really able to solve this deterministically was by mapping the flash array's volume name to the SQL Server instance name. Simple solution. There's other ways that I wanted to attack this problem, but basically, in our platforms, it will always have the volume name will always have the virtual machine's name in it. And 99 times out of 100, the virtual machine's name is going to match the operating system's name, and that's going to be how I'm going to correlate this. And I'll show you how I did that in code when we get into the demos. Anybody roll their eyes when I presented that? Because I still feel like this is dirty, but I know it works a little bit. Yeah, I know. Yeah. So, yeah, I'm sorry to cover that. So this code will all be available here. It is available there. And we're handling just the cases for vvols, RDMs, and physical. You can't really inject a lot of intelligence into this from a VMDK standpoint, because the VMDK's or VMFS data store's got lots of what, potentially, right? Lots of virtual machines running in a single data store, potentially. So I decided to not deal with that case. So let's do it. Any questions or comments, team? Awesome. Yes, sir. For this? Eugenio did implement that, actually, in Kubernetes. And I could just take this and convert it with compose with a K to turn it into Kubernetes. But I just, what's that? Oh, okay. Yeah, for this specific solution, I didn't think it was needed, because in our environment, I just have a Linux VM running this. And in Docker Compose, you can tell it, even when the system reboots, to start the container again. And so I'm getting that persistency out of the system when I do that, right? Good question. Cool. All right, so we're going to go through a couple of things. I need to give Telegraph the ability to read data for my system. So that's what's happening here. I'm creating a login and a user for Telegraph to read data from my platform. And so we're going to walk through the configuration of Telegraph now. Lots and lots of comments, but we're going to go down to the SQL Server specific stuff. I have not had the need to change any of the default configurations except for defining which SQL servers I want to monitor. And so that's what we have there. So the only thing I need to touch in Telegraph is this. If you go do this on your own, the only thing that you'll need to touch in Telegraph is that. Okay? Sir? That's why I would like to use Kubernetes, because I'd rather have this in a config map, inject it at runtime, but yeah. So, I haven't, someone asked me about this for it's going to be more of a Docker Compose thing than it is a Telegraph thing. Yeah. So, cool, good question. All right. Yeah, so we already looked at that. Now let's get into the Prometheus-ness of it. So since we're defining our own OpenMetrics exporter, and potentially you're going to be building your own, this is a part of the standard design interface that's spec'd out on the Prometheus website. And basically what you're defining here is the interval at which you're going to read metrics from your exporter or from our exporter. Those metrics will be exposed via HTTP on a web server that runs on that container, right? And so it's /metrics will have all the metrics that are going to be exposed from the devices, and they'll be collected from the devices. Which devices they're collected from, that's where this is going to come in. And so what we see here is the job, a metrics path, a credential, and an endpoint. So this is the device you want to monitor. This is an authentication credential against that target device. In our case here, we're hitting an API endpoint /metrics/array. And within there, we'll have a collection of data that's formatted in a way that's expected, that Prometheus expects. Remember I told you it's going to read from the API, it's going to turn it in a particular format, and it's going to expose it there. And this pattern repeats for different API endpoints. So metrics array, metrics volumes, and so on for the different things that we want to monitor. Okay? So that is the Prometheus elements. Now, let's look at the compose elements. I'll go ahead and fold this up like this. And so here you can see the 4 different containers that make up the platform, right? Our monitoring system, Telegraph for SQL Server, Prometheus for data collection or storage, and Grafana for visualization. Pretty straightforward implementation here. There's not a lot of parameters to fuss with. We define what the container image is, the actual command parameters to start it up. I'm building a dependency saying that this container can't start until Prometheus is available. Listing on these ports, and if the container dies, restart it. If I reboot the system, restart it, right? So that'll add some persistency there. On the Telegraph side of the house, actually, Mike, this could, you can see I can get creative around this, that this could answer your question potentially. On the Telegraph side, we're waiting on Prometheus, and I'm injecting my configuration using a volume that's mapped outside of the container to inside of the container. So we could potentially protect that in some way. permissions, things like that. Same thing, restart on failure. Cool. All right, Prometheus side of the house. Now we're going to do some things that are pretty cool. So we're running a regular old Prometheus container with some standard startup parameters defining where the configuration file is, which again is coming from the base operating system and being injected into the container. And we're also having a persistent volume for the data that's collected with that. And what is happening in here is it's going to configure Prometheus in a particular way, which I'm going to get into in a second. All right. And then on the Grafana side of the house, kind of the same pattern. Grafana uses environment variables. I'm using some pretty secure passwords there. Please change those. There's a dependency for the other two containers to be up. And I'm also importing dashboards and data sources. And this is one of the things that I wanted to make sure was easy for the consumer of this platform, because I don't want you to have to go in and connect to the database and put a connection string in and then have to go import a dashboard from JSON for some gallery. When you're done, when you do Docker Compose up, it's going to configure all that for you, all right? Cool. So let's go ahead and do that. Double check that my VPN is online and run this code here. Fingers crossed. All right. Let's go ahead and confirm that our containers are all up and running, and they are. I'm going to start up a workload. This is the new SQL CMD for Go, and they deprecated the -p parameters. All my demos have to replumb now. Yeah, I know. I get it. We don't want to have the thing be interactive, but whatever. So I am doing a couple things here. Let's go ahead and clear that. So I just kicked off a workload. Behind the scenes, hopefully this thing's actually working. We'll find out in a second. If something goes bump in the night, the logs are the way to go. And so if we look in here, if I do Docker logs specifying the container, we can already see I have an error. And this is intentional. This SQL server isn't reachable over the VPN because the monitoring system is currently on my laptop hitting some SQL servers in a data center. And so if you do have any issues, this is where you go, right, across one of these things. Because there is lots of moving parts here, and so having the logs be able to tell you the story is what's important. Okay, cool. So this is running on my laptop here, and I want to go ahead and open that up. And we will log in. Does anybody remember the password? Thank you. So what I did already, you can see here that my dashboard is imported for me automatically. So I don't have to go and get it from somewhere and import it. And now I have the data available to me to start doing visualizations with. And so this is the idea here, right? I ran one line of code, and I got this complicated monitoring platform out of Docker Compose, and it's already reading data from SQL servers in our lab environment. So as I refresh this, I check to make sure that, yeah, that's running. Okay. And so just like we looked at during the presentation, I have the ability to slice and dice across multiple SQL Server instances. So if I do identify a performance problem, this becomes very evident to me very quickly. You can see that I'm spending lots of time doing things like SOS scheduler yield again, and I'm running a large backup, so we see we're spending lots of time in backup. And now I can quickly identify which database is having an issue. We can see the instance name, AEN SQL 01, FT demo. So I'm very quickly able to identify the performance anomaly in the platform in one line of code. Going down a little bit further, here's where we see those time correlated metrics across two different devices. So I have the SQL Server volumes presenting their data, and I have the flash array volumes presenting their data. And let's show you how I was able to do that. So inside of the charts configuration, and I want to do one more thing. So localhost metrics. So this is what's called a metrics endpoint. So this is what's presented by the Open Metrics Exporter to be scraped. So Prometheus goes and reads this URL to get its metrics. And so we'll see all the metrics available in a particular format. And if I go a little bit further down, I do something like AEN-SQL 01. So this is what a metric actually looks like. So enclosed within the braces there is the data that I'm interested in. Right, so this case here, SQL Server other process, that's a particular SQL Server metric on that host and on that SQL Server instance. Okay, so SQL instance being the key metric here. Okay. Now, if I go down a little bit further, and I want to look for a flash array volume, let's go ahead and grab that. Nope. What am I looking for? It's not being exposed. Can somebody tell Jason to hush? So, actually, now I know what I'm doing. I got discombobulated there for a second. That's what I want. Oh, why isn't it there? All right, we'll save that for another show. So what I'm doing here is I'm using the sum aggregator against this particular performance metric, and across these dimensions, what I'm able to do is take that metric, which would be in curly braces, which I couldn't find in a large listing, and across those dimensions, what I want to say is that particular SQL server is going to match on the substring that is the volume name. So this is the individual volume name in the array, and then I'm taking a SQL instance and saying, let's map that together. So that's where we're able to correlate those two things, okay? And the SQL instance variable comes from the global state of this configuration here. And so what's happening here is Prometheus will go dynamically read for all the different SQL servers that exist that it knows about, and then presents to me the option, and I configured this in the chart, that I can select all or one, right? And so when I pick one, it'll clamp down to the individual one and also do that across all the different volumes associated and all the different data metrics on the different panels. Let's go ahead and get into here. So back to where we were, that's this value here. And so we're able to say across the set of all volumes, if the volume name contains the actual SQL Server instance name, that's how I'm able to correlate the metrics together, right? Very cool. And there is one other thing I want to show you. Grab. I always forget the port. Compose. Prometheus 90:90. So the absolute hardest thing to do is to build the actual visualizations. And so once I have the metrics in, and I want to make a dashboard of something, then I want to find out which metrics I want to operate on. And so if I do something like this, then I can see the metrics in a more consumable format, right? So they're exposed to me over HTTP, they're ingested by Prometheus, and this is the Prometheus Explorer, for lack of a better term. And now I can start slicing and dicing the metrics here and doing some crude visualizations inside of this particular system, which gives me the ability to build what I think is going to be right, and then take that code and pop that into the actual chart here. And that's how I was able to get these metrics to look like this. And so this language here, I could take that, put this into here, give it an actual SQL instance name. Typing in demos is never a good idea. Why is that not working, team? Oh, there it is. I'm not getting data that I wanted. Oh, yeah, there we go. That makes me so sad. All right, we'll just act like there's data there, team. No, that's wrapping. Yeah. So, anywho, that should have performed or should have spit out a crude chart. I'll troubleshoot why later. So, back to the presentation. So, one of the things I made a really bad decision about was where to stick the SQL Server metrics. Yeah, it's taking a second. I'm pretty much what I'm doing is I'm taking the data from SQL Server and exposing it on a metrics endpoint for Prometheus on Telegraph, which is a really bad idea because that scalability problem that I described earlier, that's going to be the issue. So what I'm going to do is turn this around. Instead of sticking the Telegraph data into Prometheus, I'm going to push the Telegraph data into Influx. And so as it collects the data, it's going to stick that directly into Influx rather than exposing it on a metrics endpoint for Prometheus to go grab, right? So that's where it's going to come down to is do I have a global system time that represents for me to do that, right? And so, but if that's, then you get into like refresh intervals and sample intervals and things like that, so they have to match as well too, all right?
What was the question?
Sorry, thank you. Yeah, Mike, what was the question again?
If you're adding that extra influx database, if it messes with the time correlation between the data that's ingested in Prometheus and
Yeah, okay. So the question is, by separating it out into a separate data store, is that going to influence the correlation of the timings? I'm going to rely on global system time to say that that's the case, right? And if you think about what I'm going to visualize on a sample interval, and I'm going and collecting, right? That's going to be in some interval. Right now, it's 30 seconds, right? So you're thinking like if it's like 15 and 30, right? That would be a bad thing. So yeah, you'd want that to be timed across those. So key takeaways: try it out. Hopefully I showed you that it's very easy to set something like this up. And yeah, you may or may not have a flash array to try this against, but you can do this in other things, right? You can start correlating metrics across VMware, maybe into Azure, you know, as if you have more complex hybrid systems, and definitely, obviously, in the database tier. I'm gonna go ahead and link to here so you can see the code that supports an implemented exporter from what we talked about today. And I blogged about this here. So if you want to go a lot describing exactly how to get this all set up in your environment. And then what I'm going to do next is flip that around, get that in Influx. And I've been playing with this. It's one of the reasons why I sat in Joe's session yesterday is I want to bring VMware metrics to the party too, right? Because in our world, and who's running SQL Server on VMware? Yeah, at least half the room. In our customer base, it's nearly 90% of our customers that run SQL servers run them on VMware, which is a crazy number if you think about that. And so being able to give a data professional visibility across that entire stack, I think, is extremely important. And that was the gap in one of those metrics where I had the disconnect between what the flash array was presenting and what SQL Server was seeing. And so I'm going to fold in the VMware one so I can very easily say that's the bottleneck. And so there would probably be a metric that I could expose that's something like queuing, which is going to be important there. So wrapped up a little bit early, but I'll open it up for any questions or comments, team.
two questions actually.
Uh-oh.
First question is, well,
Absolutely. Yeah, so the question or more comment is, I focused a lot on storage in that example for correlation, but yeah, definitely if you want to look at the potential for latency when coming from other parts of a system, when I highlighted specifically the healthcare case, that was a switch issue or configuration of a switch issue. In this case here, we are walking through the rest of the elements, so CPU, disk, RAM. I had to stop somewhere with regards to how much I wanted to get in here, just from a learning standpoint, because this is obvious, this isn't a production platform, but I wanted to help educate folks on how they can leverage this in their environment. So if your thing spits out data, you can stick it in a chart like this. So Telegraph, so the question is, do I see the path forward for this for hybrid and cloud? Yes, because in the end, what you're gonna have, especially if you're using like a Azure tool to monitor Azure, and VMware tools or on-prem tools monitor on-prem, there are systems that reach across those boundaries, right? And so you can emit those metrics, collect them, and correlate them. Now, how fast they're going to come out, that's going to be just something you're going to have to solve for, right? So, all right, so the question is, how do you affect this type of visibility in a large organization that's siloed, right? That's a people problem, right? And in the end, management is going to have to be the one that says, I don't care whose silo this is. We need to focus on the outcomes for the business, right? And in that specific scenario, the director of IT was like, my physicians are sad. We need to make it better, right? Because if you have sad physicians, they're skilled people. They'll just leave and get a job somewhere else, right? And so that's the real challenge has to be solved. And so when you, especially as a consultant, my number one skill set wasn't me clicking a mouse or running PowerShell. I was able to operate across organizational boundaries to solve problems like that, right? And so I put all those nerds in a room, and the one person that didn't have data just happened to be the one that had the problem, right? There's a funny story that I can tell you offline about the rest of the conversation around that involved lots of 4-letter words. So, cool. All right, we good? Awesome, thanks team.